Hello, we are starting a new chapter today, and this chapter is all about percents. We're going to do some quick review in this video about how to change between percents, fractions, and decimals so that we can move on to some more interesting problem-solving situations involving percents later on in the chapter. Alright, let's start by figuring out or reviewing how to change from a decimal to a percent. Okay, well, one way you can do it is change that decimal to a fraction. So reading this number, this is 375 thousandths. We know that because the last digit is in the thousandths place, tenths, hundredths, thousandths. So this is 375 over 1,000. The word percent means per 100, which means over 100. Actually, that's not quite right. The per actually is the division symbol, so we would just say per 100. The per and the cent, 100. So we want 375 over 1,000 to become something over 100. And I know to divide, to turn 1,000 into 100, I just need to divide by 10. So to divide by 10, we just go back one space here. Go back one space. And so my answer is going to be 37.5. Let's look at this one. 0.27 is the same as 27 over 100 because the 7 is in the hundredths place. And so since we already have our per 100 or our percent, the top number is already the answer. So 27. I forgot the percent. So it's 27%. This previous one, sorry, was 37.5%. Over here, we have 6/10. We need the bottom to be 100, so we can multiply by 10 to get 100, right? So we're multiplying by 10, bringing that over 1. So it's actually 60 over 100, which is 60%. For those of you who remember last year, we worked on changing decimals to percents, and we know that we can just move the decimal 2 places to the right. So notice 37.5, here it is, 27, here it is, and 60. Remember when there's an empty scoop there, you just put a 0, 60%. So one reason I went through it using this the fractional method here is because sometimes students can forget which direction the decimal goes when they're changing from decimal to percent or percent to decimal. This is a real easy way to just prove to yourself that you're getting 100 on the bottom, and so you don't need to memorize the direction here. But if you already have or you're comfortable using this movement of the decimal method, then feel free to do that. Alright, percent to decimal, kind of very similar to what we just did there. The word percent means per 100 or over 100, so I know that 88% is 88 over 100. To make that a decimal, that's 88 hundredths, so 0.88. This one we have 256 per 100 or percent. So 256 hundredths, that means that the 6 has to end up in the hundredths place, so that's actually 2.56 or 256 hundredths. Another way that you could prove that to yourself is you could say, I don't know, that wouldn't work, but you can make that a mixed number, 2 and 56 hundredths, right? So that would prove this as well, right? And then 7%, we have 7 over 100, which is 7 hundredths, which means that the 7 has to be in the hundredths place of the decimal, and so we end up with that. Also, similar to what I said before, just moving the decimal will work here. So Anytime you want to change percent to decimal, you just move the decimal back 2 spaces. Notice none of these actually has a decimal in it to begin with, so it's always just at the end there. There you go. One of the biggest mistakes that students make is when they have like one digit, like 7%, they'll just write 0.7, which is not the case. Remember, every time it's a 2 decimal movement. Alright, moving on. Fraction to a percent. Sometimes this can be very easy because, as we know, the word percent is over 100. So to make this 50 into 100, I just multiply by 2, which I would also have to do to the top. It didn't look very good. Multiply by 2. And so we would get 46 over 100, and so we just say that's 46%. It's not always so easy as this example. As we move over to the next one, 7 over 800. To get 800 into 100, we have to divide by 8, which 7 is not divisible by. So when we can't easily turn the denominator into 100, we just do long division. So 7 divided by 800. Remember, our decimal needs to go right up into the answer. I know I'm going to need some extra zeros here, so I'll just put them in. 800 does not go into 7. It does not go into 70 or 700, but it goes into 7,000, I think, 8 times. And so that would be 6,400. Kind of went diagonal here. I'll try to line it up. And so the remainder there is going to be 600. And so we're going to need to keep going. So we're going to bring this down. The instructions sometimes in this case will say round to the nearest tenth of a percent. Okay, so in this case we're going to get a decimal answer, not a percent answer. So remember, to change the decimal to a percent, we're going to move that over twice. And so we are already at a tenth of a percent, but we need to round, so we're going to go one more digit. So 800 into 6,000 is going to go, I think, 7 times 5,600. And we don't really need to do that because we have the digit that we wanted. So it's going to be 0.009%. I'm sorry, not 0.00. 0.9%. There we go. 0.9%. So let's see if that makes sense. If we were to turn this 800 into 100, we'd need to divide by 8. Well, if we divide 7 by 8, we get a number less than 1. So this has to be less than 1%. So 0.9% makes a lot of sense. So we're not going to be able to turn this 450 into 100 easily with division. So we're just going to end up doing long division with 41 divided by 450. Now, knowing that we're going to be doing a percent, we know that we'll need 2 decimal places at least, probably even more. I'm going to leave room there for it. So let's see what happens. So 41 does not go into, or 450 doesn't go into 4 or 41 or 410, but it'll go into 4100, I think, 9 times, which would end up being, let's see, 4,050 with a remainder of 50. And then, as we suspected, we're going to have to bring down another 0. So 450 goes into 500 one time. Now we're already, so the decimals here, we're already going to need to move it over twice. So that's, so far we're at 9.1%. Now we need to round to the nearest tenth of a percent here, so we only need to go one more digit. So let's keep that in mind. Okay, it looks like we are going to be repeating anyway here. So it's going to be 9.1 repeating. And so we just say 9.1. Actually, we're rounding, so you wouldn't put the repeating symbol. You would just put 9.1%. That's it. All right, so now percent to fraction. The first part of this is really simple because we know the word percent actually means per 100. So we just say 6 over 100. Now whenever you change a percent to a fraction, you're always going to want to reduce that. So 3 over 50 will be our final answer. 37.5%. Don't be scared by this decimal here. Start it out the very same way. Right, 37.5. That symbol means over 100. Now we need to realize that you can't have a decimal in your final answer because you can't have a simplified fraction with a decimal. So now we just multiply it out. So if we multiply the top and bottom by 10, we end up with 375 over 1,000. And now we have to reduce. I know both of these are divisible by 5. Doing division here, like 375 divided by 5, 1,000 divided by 5, and go from there. These are pretty big numbers, so I'm going to make some quick factor trees. I think that might just be the fastest way. I know this is divisible by 25, and so what would that be? 4, 8, 12, 15, and let's see, this will be 10 and 10. Ooh, I'm going to go triple here. 10, 10, 10. So that's going to be 2 and 5 for each one of these. So I'm going to end up with 2, 2, 2, 5, 5, 5. And over here, I'm going to end up with 5, 5, 3, and 5. So if I take out what they have in common, which looks to be 5, 5, 5, right? 5, 5, 5. The remaining stuff should be my simplified fraction. So 3 over 8, 3/8. Let's move this down a little bit. 3 over 8 is my simplified fraction. Now, 10.5%, just like this last one, don't be scared by this 0.5%. There's a couple different, actually there's a few different ways you can attack this problem, and the more comfortable you are with fractions, you'd probably want to do it with fractions. If you're comfortable with decimals, you could do it with decimals. So since we just did one with a decimal, I'll continue with that. 10.5, same as 10.5. The percent thing is over 100. So right there, we're almost done. We're at an easy point there. We can multiply out the decimal. Now we need to reduce, and that's it. So dividing by 5, I think, would give me 21 over 200. And then, let's see, 21 is only divisible by 3 and 7, which 200 is divisible by neither of those, so that we are done with that. Another way you could have attacked this problem is you could have said 10.5 over 100, which starts out looking kind of weird. But remember, this is just a division bar, so I could change this to 21 over 2 divided by 100, which is the same as multiplying by 1 over 100, right? Multiplying by 1 over 100. And then we know that it's 21 over 200. So either way you want to attack that problem, you can do it. You'll get the same answer. Is acceptable. So, and the last example, if we wanted to order these from least to greatest, one thing we should probably do first is to put them in the same form, right? So if we want to put them all in fractions, it'd be easier to compare them. Maybe all in decimals might be easier to compare them. So 0.68%, that's a very small percent. As a decimal, that's actually 0.0068. 0.37 is already in a decimal. 3 over 10 is 0.3. So from least to greatest, it goes 0.0068. That's the very smallest one. 0.3 and 0.37. And that is it.